Hi, everyone. Back to sets. This, by the way, is called a Venn diagram, which is a graphical way of representing a set. Venn diagram, a graphical way of representing a set. So, for example, 0, -1, and 7 are elements or members of the set of integers. Z is a subset of Q, and so forth. Let's talk about set notation. So this sort of curvy E denotes in or is in. It denotes set membership. So for example, 7 is a member of the set of integers. 7 is in Z. In plain English, 7 is an integer. Okay, 7 is inside the disk for integers. If you slash something, that tends to negate the operator. It tends to mean not. So this sort of epsilon symbol with a slash through it, that denotes is not in. 1/2 is not an integer. 1/2 is not a member of Z. 1/2 is not an integer. This is more rare. This backwards E guy denotes such that in some settings. We don't use that too often. In fact, later on, we tend to use a bar for that, for such that. These two guys you see a lot in calculus theorems. The upside down A, the universal quantifier, denotes for all or for every. So for example, in a calculus theorem, you might see something like this. For every x in the set of real numbers, da 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 da. In other words, for all real numbers x, for all real numbers x, we say that this statement is true. For example, for all real numbers x, it's true that x is less than x plus 1. That's true for all real x. The backwards E is the existential quantifier, and it means there exists or there is. These you find in existence theorems. Don't worry, I'm not going to have you parse things like this in our class, but you do see these kinds of theorems in calculus. Blah, 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 there exists a real value y, such that da da da. So here are some set notations. Next, we're going to talk about subsets of real numbers.